Okay, right, yeah. Good morning, everyone. Welcome to this timber industry EPD awareness training session. So we're going to be hopefully running this a few times. So any of your staff you think need to come along to this training, let us know, and we can always put on another session later on in the year. So lots of questions around EPDs, which is what's really formed the agenda today. So what is an EPD? Why do we need them? What data is included in an EPD? What's the process of attaining an EPD? How does an EPD for timber differ from EPDs for other construction materials? And that's generally around accounting for biogenic carbon. And how does the designer or specifier use that EPD for their whole life carbon assessment? So that's the sort of questions that we've had come in, and we've sort of framed this training around those key questions. And we've added a bit on at the end. Hopefully, we'll get time to go through that about measuring your emissions, tied in with a net zero roadmap, and also maybe some tools and other actions that you might want to look at. So that's what we're going to try and cover today over the next, I think, 45 minutes or so. So, firstly, what is an EPD? So an environmental declaration is a what they call a Type 3 environmental label, which quantifiably demonstrates the environmental impacts of a product over its life. So it's based on a full life cycle assessment of the product, and it generally uses what we call approved product category rules for the different types of product. The impacts disclosed aren't limited to carbon. I know we talk about EPDs a lot about about carbon, but they're not limited to carbon or what they call global warming potential in the EPD. There's many other impacts which we'll touch on as we go through, but carbon is obviously the main one that people are asking for at the moment. Now, to become an EPD, that life cycle assessment that's done is basically assessed and verified in line with the approved standard, and that's generally in Europe. It's generally EN 15804, but if you've got international companies, that can be ISO 14025, and it's usually valid for around 5 years. A life cycle assessment. What do we mean by a life cycle assessment? So it's just life cycle assessment is split out into sort of four main phases basically. There's A stage, which is split into two. So you've got A1 to 3, which is your sort of what you call your product stage. So that's your raw material extraction, transporting that material around within the production process. So, for example, moving the logs from the forest to the sawmill, and then you've got that manufacturing process, i.e., sawing those logs into a piece of timber. But that could be more than that. Obviously, if you're doing things like CLT, glulam, plywood, there might be a few more stages involved in that A1 to 3. But they're all included in that A1 to 3 stage. You've then got sort of getting that product to the site where it's going to be used, so transporting it from the manufacturing facility that may go via a merchant to the construction site, and then you've got the point of putting that material in place on the construction site. So that's what we call the first stage there, and sometimes known as the upfront stage. So that's the A1 to 3 is probably the key bit of information that you'll get in your EPD, and we'll talk a bit more about that later on. You've then got what we call the in-use stage. So any maintenance that might need to be done, does it use any energy? That's sort of covered in the sort of next bit where we talk about operational carbon, and most timber products don't use that, so we don't have to worry too much about operational carbon and operational water. But we might have to maintain them, we might have to paint them, we might have to repair elements of them if they rot away and we haven't specified the right material, for example, will last a certain amount of time, and in some cases that might mean complete replacement of that product. And then we've got the end of life of that product, so actually deconstructing the building, or removing the product from the building, transporting that to some form of waste processing facility, and that either it might end at that waste processing facility because then it becomes a raw material for something else, so I recycle it, or it's disposed in. And when we talk about disposal, we're talking about landfill there. In that situation, there is also what we call stage D, which it is sort of goes beyond the building life, and this sort of the idea of stage D, sort of benefits timber can be added here for example, avoiding the use of virgin product in lieu of recycled product, or using biomass instead of a fossil fuel when you're sort of generating energy or something along those lines. So those are the types of things that you can put the benefits. They don't form part of the overall the calculation for the EPD, but they are sort of those additional benefits of that product or material. Like I say, for the EPD, there are some key sections that you must have. So A1 to 3, C1 to 4, and D are the minimum you will need to measure for your EPD. The others are all optional at the moment. Like I say, the key standards, we sort of touched on these earlier on. There's an international standard, like say ISO 14025. And then the European one, which at the moment is 15804, and that's sort of there's like what we call the plus A2, so the 2019 version of that standard, because it was updated in 2019, so what we call a plus A2 version. Linked to that, you have got what we call the product category rules for timber. So round and sawn timber products have their own product category rules, which go into a bit more detail on what's the information is required. And it basically expands on what the requirements of 15804. And that's, like I say, that's BSEN 16485 is the other document you might need if you're going to produce an EPD. Just before we move too far, I just want to sort of touch on some terms that we're going to be using here today. Which we talked about, we've touched on some of these already. So net zero whole life carbon. So that's sort of a net zero whole life carbon product or asset is one where the sum of all the assets related greenhouse gas emissions, both operational and embodied. So i.e. when we talk about that assessment, it's A1 to 5, B1 to 7, C1 to 4, and any offsets in the form of carbon removal equals 0. So that's what we mean when we talk about net zero. Whenever we talk about net zero, that's what we're talking about. When we talk about embodied carbon, we talk about it's basically greenhouse gas emissions associated with the material, construction, maintenance, demolition processes throughout the whole life cycle of the product or assets. So again, looking at those modules, we're looking at A1 to 5, B1 to 1 to 5, and C1 to 4 in that situation. So obviously not the operational carbon we talked about, which is B6 and 7. And we talk about biogenic carbon quite a bit as well. Obviously, that's carbon derived from biomass, so that could obviously trees, but could include other grown material like bamboo, hemp, those types of product that we might see as well used in construction. And then we talk about carbon sequestration. So that's the actual process of removing CO2 from the atmosphere and storing it in a stable long-term carbon reservoir, e.g. The fibers within timber in a tree. And there's a lot more glossary terms there on the Timber Development UK website, but just want to sort of touch on those four that we're going to be talking about quite a bit today. So why do we need an EPD? Well, I think we're all aware that we are sort of in a climate emergency at the moment, and we've had some of the hottest temperatures on record over the last 10 years, and we really need to be doing something about that. And some of the key actions that have been promised, both internationally and in the UK, is we've said that at the Paris Agreement in 2015, so this is nearly 10 years ago now, we said that we needed to limit global warming to well below 2 degrees and preferably 1.5 degrees compared to pre-industrial levels. We're already hitting 1.48, so 2023 was the hottest year on record of average temperatures of 1.48 degrees above pre-industrial levels. So we're already very close to hitting that at the moment, and we're a long way off from 2050, so we really need to be doing something fairly urgently. The UK government has set targets to reach net zero by 2050. That was set in 2009, and it also set an interim target in April 2021 to reach a 78% reduction by 2035 compared with 1990 levels. So there's quite a bit of work to do there. We're not on track for any of those targets at the moment, and I know the new government, and if you see the latest Climate Change Committee report that came out last week, they were sort of saying the new government's really got to act quickly to get back on track for those targets. And there's obviously lots of targets for individual organisations, including people like the Construction Leadership Council, World and UK Green Building Councils, and lots of manufacturers, merchants have set their own targets as well. And you know, TD UK has got a target. We signed up to the SME Climate Hub commitment. So where we said Timber Development UK recognises that climate change poses a threat to the economy, nature and society at large, and commits to take action immediately in order to support our members in halving greenhouse gas emissions intensity by 2030, achieve net zero by 2050, and disclose our progress annually. So that's we've signed up to that to help you, our members, achieve some of those targets. And hence we've got things like the net zero roadmap and this training to try and encourage you to do something about it. And obviously we're here to help if you've got any questions. So that sort of, a lot of that's sort of formed part of the timber and construction roadmap as well, which was released in December 2020, which talks about utilising timber in the built environment will support progress towards net zero. Built environment is 25% of UK emissions. Timber construction can help reduce the whole life carbon of the built environment, and obviously where timber has been harvested from sustainably managed forests, timber products also act as a carbon store, locking away that carbon for the duration of the product's life. So, all the benefits of timber associated with carbon. So what we've said as an industry, we will obviously help reduce embodied carbon through use of encouraging the use of the Future Homes Hub, delivery plan and built environment carbon databases, very much aimed at more so the architects there side of the membership, but also encourage the inclusion of data on projects on BECD and improve the quality of EPDs by 2028, including creation of our EPD database. And we've got that EPD database up and running now, and we'll talk about that a little bit later on. But one of the key bits, which I think we're going to see coming down the line, is a new. We've sort of termed it Part Z at the moment. This is an industry initiative encouraging the government to actually require the assessment of whole life carbon emissions for all projects, but starting off with major building projects, and also limiting the embodied carbon emissions within them. So not just measuring that carbon, but also setting limits per square meter of the amount of carbon that can be produced. And if we get that, that's going to be a big plus for timber products, because obviously timber generally does have a low embodied carbon. So definitely something we need to be supporting as that, but to be able to have our products assessed correctly, we need to have accurate data on the carbon that's embodied within them. So that's really where that EPD comes in. So what data is included in an EPD? Well, initially there's sort of some key information, and we're using just so you know, I'm using an example here from Store Enzo. We'll refer to this all the way along, just as it's quite well laid out. This one, it's very easy to read and easy to understand. So there's obviously a lot of EPDs out there at the moment, but this one is one of the easiest ones I've found to actually interpret. So it will tell you a bit about the organisation and description of the product. It was also talk about what the declared unit is, and generally for timber and products we're talking about per cubic meter, so we can try to compare them with similar timber products. So if we can try and stick to that, if you are doing an EPD, even if you're using got a sheet product that you're selling square meters, it's better to convert that back into a cubic meter data. It will also give you the composition of the product. So obviously timber's an easy one. It's wood, 100% wood with a moisture content, and it should give you the moisture content in there. In this one case, it's sort of 12.7% plus or minus 4.2%. So that gives you an idea of the moisture content, because that's important when you try to work out the biogenic carbon. You have to take that moisture out of the product to calculate the biogenic carbon, and that's the next bit underneath there. It gives you the biogenic carbon figure there. So works out about, for this product, about 733 kilograms of CO2 per cubic meter of sawn timber there. So that's the sort of key data that comes up front. You'll then get all the impacts from different areas, and obviously the main one that we talk about there is, like I say, global warming potential is the key one, and that's broken down into things like fossil carbon. So fossil carbon is energy. So if you're using diesel fuel to fell timber in the forest, that's where that's accounted for. Your biogenic carbon is your sequestered carbon in the timber, and then you make an allowance for your land use and land use transformation. So that's the carbon that might be lost from that process of felling the tree by disturbing the soils, etc. And that's all added up to give you a total figure, which in most timber products will be near enough all timber products will be a minus figure. You'll see there that there's it talks about 7.2 plus O2. That's what we call scientific notation. or sometimes known as standard form, and the E stands basically exponent. So it's basically instead of using sort of superscript to denote the 10 times, they use that plus 1 or +2, and what it means is you have to either move the decimal point over 1 or back 1. So just to give you the actual figures here, for this data. So where we've got the 3.99 plus 01, that in effect means 33.9 kilograms of carbon, because it's the +1, we move the decimal point over 1. For minus 733, it's a minus figure, but we've got a +02, so we've got to move the decimal point over 2. So that gives you, so it's a minus 733 kilograms of CO2 for that one. And then the land use transformation, that's a 7.08 minus 01, so we've got to move the decimal point back 1. So in effect, that's 0.71 kilograms there, giving you the total of the 698.39, which is the final figure there. So that's how you convert those EPDs if you're reading them. Like I say, there's a lot of other data included in there, things like ozone depletion potential, acidification potential, etc. All of those are important impacts that we need to take account of. They're just not being asked for at this particular time. I'm sure they will be in the future, and a lot of this data will come from, like I say, standard calculations. You haven't necessarily got to calculate all this yourself, as long as you've got initial input data on the energy that you're using, water that you might be using in the process. There are calculation methods that will give you that data. So some of the key data that goes in is obviously your primary energy resources, renewable energy resources, etc. Secondary materials that are going into it, etc. Any hazardous waste disposed of. Generally, timber's pretty good on that. There isn't any unless you're using a lot of maybe recycled product. And obviously think, output flows and stuff like that. So like I say, don't panic. You will not need to measure all of these impacts yourself. Like I say, many are obtained from the generic data sets. So for example, EcoInvent and Gabi databases and stuff like that. So it's not stuff you need to measure as long as you know what the quantity of timber is that you're putting into that input. So to obtain that EPD, there's a number of stages that you need to work through. So these are the key stages, and we'll look at these. So defining EPD, data collection, life cycle assessment, a background report, third-party verification, and then publication. So as far as designing a strategy, first thing you need to consider is whether you're actually going to produce an EPD for a single product. So, one product within your range, or do you do it as a product group? So, for example, do you make an EPD for your, sawn 100 by 50 timber, or do you do it for your whole range of sawn timber? In most cases you do it for your whole range of sawn timber, because the process of producing that piece of sawn timber is the same, and you can average the data over the whole set. And like I say, because you're reporting it per cubic meter, it doesn't really matter if you're producing 150 by 50 or 100 by 50. It doesn't really matter in that situation, because you're going to pare it down per cubic meter and have it as an average anyway. It's not an exact science. It's getting it as near as we can. It could be a product group, like you say, and that's probably more likely. Or you can do what we call an industry average, so an average of a number of manufactured products. So if you've got a close working relationship with a number of people in the industry that produce a similar product to you, it may be that the industry body might produce its own EPD. An example of that is sawn timber. At the moment, it's being renewed at the moment, looking to be renewed, but we've got a number of the sawn timber providers in the UK are coming together to produce a single EPD for their products. So that can help obviously spread the cost out across a number of companies and keep the cost down. The other thing you need to then consider is whether you look to outsource that the production of that EPD, or whether you want to do that in-house. And if you've got a lot of products, it might be worth investing in training someone up to do it. You might want to identify obviously the product category rules for timber. We've obviously mentioned those, but if you've got other products in your range, you may need to double check the product category rules for those, and also who you might want to use as what they call the program operator for the approval and publication process. The other thing you need to look at is in the data stages that you need to assess. And like we said before, you need to do A1 to 3, C1 to 4, and D. So A1 is your sort of includes your biogenic carbon contents. That's where you'd say, right, this piece of timber can include so much CO2, but also you'll have emissions in there from your from the extraction process and processing of the raw materials. So that's things like maybe harvesting and sawing in that process. If you're producing a piece of CLT or something, then all that might be in an A1. You then got the transportations from the extraction location up to the factory gate, including that in any internal transport that you might have within your business. And in A3 is that manufacture the final product that you're going to sell. So, and also the co-product. So how that co-product is dealt with as well would all be part of that process, and also any packaging and processing of waste that you might have to do. So that's the bit that you will have some really good data on, or should have some really good data on. That's the bit that should be the most accurate. You then got to make assessments on the end of life scenarios, and like I say, we've got some good data on what happens now, and unfortunately, that's what we've got to base the EPDs on. We should be basing on almost what the situation is now, not necessarily what we think is going to happen in 50 years' time when this piece of timber comes out of the building, because that's a bit of an unknown. So we've got to include all of that all that processing that we're doing now in the process, and then, like I say, look at those benefits beyond the product system. You then obviously need to collect data. So the sort of data you're going to need is your material input quantities, including sort of any moisture content, inputs and outputs, materials there. Any energy inputs such as diesel, fuel, biomass, electricity that you're putting into the process for things like kiln drying and sawing, for example. Any co-product outputs, because they obviously then might get deducted and go into another product system. Any waste produced from the product process that you have to dispose of. Any other emissions from the process, so any fugitive emissions that you might have, if that may be off gas or anything of the product, not necessarily something you have too much of for timber. Obviously, any transport data, so miles or kilometers traveled and or the fuel used for that process, and also obviously developing those end of life scenarios for your products. You'll then need to carry out that life cycle assessment stage. So that's, like I say, whether you use an external consultant or in-house using some form of LCA software, one-click LCA or or other type of system there that we might have. Obviously, the scope that you're going to cover. So, like I say, the minimum is that A1 to 3, C1 to 4, but you might want to include some transport to the site. That's up to you. And then obviously data that you've got there will feed into those impact category calculations. Not just carbon, it will include lots of other impacts. And then you produce what you call the LCA background report. So it includes essential details, values concerning life cycle stages, inventory. It basically it's telling the assessor what you've assumed or what you've accounted for within that life cycle assessment. So it might include key concepts like the co-product allocation, end-of-life assumptions, etc., selection, validation, and quality of the data that you've got, and if required, a sensitivity analysis of how good is the data that you've got for certain sections. So some might be really good because it's based on your own data. Some might be not so good because you've got that from industry averages because you haven't got the data yourself. And then once you've got that, you can then submit that for verification, and that would be one of the, like I say, the online program operators. You'd submit it to them. They would then assess that EPD, or their assessor would assess that EPD, and hopefully pass it so you can publish it. So you can then publish it once it's verified and your EPD is ready for publication, and you've paid the hosting fee to the program operator. That's it, your EPD is published, and that generally lasts 5 years. That publication process will be held on their website for around 5 years, 4 or 5 years, sorry. So that's the process of getting an EPD. As far as accounting for The biogenic carbon. This is sort of the bit that confuses some people. Hopefully not too much. You guys will hopefully know that from our sort of O-level biology classes that trees absorb CO2. They breathe in CO2 from the atmosphere and emit oxygen, and obviously the carbon element from that CO2 mix is laid down into the fibers of the timber. And like we said, that cubic meter of Swedish spruce from the Stora Enso EPD stores the equivalent of 733 kilograms of CO2 per cubic meter of sawn timber. That carbon stays in the product. It's not released until either decomposes or is burnt. So however many times we recycle that timber fiber, as long as it's not doesn't get broken down and biodegrades or isn't burnt, that carbon stays locked in that timber forever. So the only time it is released, like I say, is when it decomposes in landfill, or more likely in the UK, it gets burnt biomass plant. Whether that's your biomass for your kilns, or a commercial plant generating electricity, a Drax power station or something along those lines, that's the only time that CO2 will be emitted back into the atmosphere. There is obviously a question mark around that of the timber that we're producing now. Will that actually ever be released? We've got to talk about what we call bioenergy carbon capture and storage, or BECCS for short, where actually in 50, 60 years' time, when this piece of timber comes out the building and it gets burnt in that type of plant, the carbon from that process, or CO2 from that process, will be captured permanently and stored somewhere else, whether that's in things like biochar or in underground caverns, whatever it might be. We might not emit it to atmosphere, but we're not allowed to take account for that process at the moment in the current EPDs. So when you calculate your biogenic carbon content, the product categories we talked about, BSEN 16449, states that half the dry mass of timber is carbon. So that's setting it out. So half the dry mass of timber is carbon. So the dry mass is calculated by taking the mass of the timber, including moisture content, and then dividing this by 100% plus the moisture content. Therefore, what that gives you is that if we've got 460 kilograms is the mass of the timber, including the moisture content. So we're assuming that it's 100% plus a 15% moisture content. That equals a dry mass of 400 kilograms. So we're dividing the 400 by 115%, gives you that 400 kilograms. Therefore, the biogenic carbon content is half of that dry mass. So 400 times by half gives you that 200 kilograms of carbon. I think in the Stora Enso one, it's 199.99, but we'll round it up to 200 kilograms. BSEN also sets out, BSEN 16449 also sets out the formula for calculating the sequestered carbon. So that's the actual, what we call the carbon, but the amount that would have been sequestered by that tree to create that carbon is basically the dry mass times 0.5 times 44/12. And I won't tell you where that 44/12 comes from. It's just the figure that we have to use. So what that gives you, the sequestered carbon, therefore, is 400 times 0.5 times the 44/12 gives you that 733 kilograms of CO2. So that's how you calculate the carbon and the CO2 content of your timber product. So treating the biogenic carbon, the product category rules also set out how we can treat the biogenic carbon within a life cycle assessment. And what it says is where timber is obtained from sustainably managed forest, the biogenic carbon or CO2 figure can be included in A1 as a negative emission. But where no evidence can be obtained of the timber originating from sustainably managed forest, then the biogenic CO2 figure cannot be included in A1. So this is why it's very important that you've got your due diligence in place to be able to say that your timber comes from a sustainably managed forest. Easiest way to do that is through certification, but if you haven't got certification for your product, there are other ways around it. At end of life, the biogenic CO2 figure is then added back in as a positive emission. You sometimes might hear what we call this minus one plus one calculation for biogenic carbon. So in C3, that would be added in as in C3 as a transfer of carbon to a new product system. If the wood is or wood-based product is be recycled or reused, it will go in as in C3 as a transfer of carbon to a new product system. If the wood is or wood-based product is to be sent for biomass. Which obviously that subsequently emits to air, but it's not within our system, it's within the energy generation system in that situation. Or it goes in as a C4 as an emission if the carbon or wood-based products can be sent to landfill. So just to try and demonstrate that, I'm trying to whether this works, I'm trying to sort of demonstrate this visually. So we've got our 1 cubic meter of timber product, and we've got what we call our new timber product system. So that's the dotted line. So when we talk about product system, it's something within a set defined boundary. So what we will have is obviously within our defined boundary, we've got a tree which is sequestering carbon out the atmosphere, and we know that that's 733 kilograms of carbon per cubic meter of timber. When that's converted into a piece of timber, that 733 kilograms of CO2 still goes into the cubic meter. Obviously, we're going to have co-product and waste coming out of that, which may go into what we call a co-product system. So what we'd do there is we'd take that 733 would be in effect emitted from our timber product system added back into our timber product system and then minused out again for the co-product system, say a chipboard, for example, a chipboard panel product. So they can then take account of that 733 kilograms of CO2. At end of life, obviously, we need to add that sequestered carbon back in so that it can be used again by the next product system. So if it's a recycled product system, again, you probably use some recycled chip in your chipboard so that they can take account of that 733. We in effect plus it back into our system so that it can be minused from the next system. If there's any waste from the production process, or if it goes into biomass, for example, that would then be again a plus into our product system, so that the other system, i.e. the biomass energy producer, for example, can then take account of that in their electricity generation. And hence why when you sort of hear electricity generation using biomass is classed as carbon neutral, sometimes it means basically saying, well, we'll take account of the CO2 coming in so that when it's actually emitted at the other end, that's exactly the same CO2 figure. So the net figure is a zero CO2 to our process. So what it's saying is, in effect, you've got CO2 in the atmosphere is the same as what with CO2 in the atmosphere at the start of the process, because we've sucked it out of the atmosphere into the tree, and then we've just emitted that same amount back out to the atmosphere at the very end of the day. But in between time, we're swapping that CO2 between different product systems. Hopefully that tries to explain it a bit better. It's a bit difficult to explain, but hopefully that makes some sort of sense. So how does the designer or specifier use the EPD data going forward? So the building life cycle assessment uses exactly the same process. So where we talked about A1 to A3 products and A4, 5 construction stage, the designer's doing exactly the same thing here. They're using all of those different stages. What they will have is obviously they've got the embodied carbon there that we talked about. So what we call the A1 to 5, the B1 to 5 and C1 to 4 is what we call our embodied carbon. And what sometimes is you got your operational carbon is your B6 and 7, but what you've also got is what we call our upfront carbon as well, which is the what we call the A1 to 5. So if you hear the term upfront carbon, that is what they mean by the carbon emissions to practical completion. Okay. Let's generally work into what we call the RSCS Whole Life Assessment for the Built Environment Standard. That was second edition of that was released last year, and that's based on the existing standards that are out in the industry. So BSCN 15978 is the standard that's based on. To get the data into that whole life carbon assessment, obviously we need that EPD, and that's why EPDs are so important, because we need to use the data from the EPD to calculate the amount of, so if we know how much timber is going into that building, we can then use the figures from the EPD to work out the whole life carbon. Um, there are some obviously steps that might happen in between. So we might have what we call assemblies and sub-assemblies. So if we've got a timber frame, for example, house, we're going to have our raw timber product from Store Enzo. But we need to, that goes into a sub-assembly before it goes into site. We might need to do a little calculation before then, before we hand that over to the designer. And that's where things like the AECB carbon calculator tool come in. So that means you can then sort of take your Stora Enso timber, your OSB from, say, Norboard, your nails and metalwork from your metalwork supplier, put all that into a calculation and say, right, this is the, excuse me, this is the embodied carbon for our assembly, which can now go into that whole life carbon assessment for the building. So the way the building assessment works is very similar to how we've sort of just explained it for the carbon going into timber. So over the life of the product, so the actual sort of flow of carbon is something along this line. So we've got our timber, our softwood growing, our tree growing for say 50 years before it's felled. There's obviously an initial, so that's sucking carbon out the atmosphere, and we get down to our 733 kilograms. There's in obviously a jump where we actually got positive carbon emissions because we're using fuel for our harvesters and forwarders, and we're moving that around on a truck, and we're using energy in it, and you know, gas maybe for kilning and electricity for sawing. So there's obviously a carbon impact there, but that gives us a net impact, which is that dotted line going off into the distance. So the standards use the same sort of approach, and obviously, sorry, there's obviously stored carbon in that in that approach. Now the standards use a similar approach, but what they require is for you to set a lifespan of actually sit for most buildings is actually 60 years. So you have to, that's where, so they require you to add back in that biogenic carbon after a 60-year life cycle in effect. So you end up with a net positive whole life carbon emission in effect. But that's just how the standard makes it work. So that's how they will use the data. And like I say, when they're doing a whole life assessment, if they're doing a whole life assessment, they can use the figure from your EPD that includes the biogenic carbon. So they'd sort of in effect have that additional, for example, 733 or 750 kilograms of CO2, and then they'd add it back in at the end of life as a transfer over in C3 in the same way we would do in an EPD. Obviously, if they're just doing an upfront assessment, though, they're not allowed to include the biogenic carbon in their data. So what they have to do is show that as a separate stored carbon figure. So like say, e.g. the 733 or 750 kilograms of CO2 per cubic meter would be sort of shown as a separate figure, and they'd only be able to include the fossil and LULUCF positive emissions in the calculation. Let's say to do that, all that timber must be from a verifiable sustainable source. So again, like I say, if you're using certification, PFC, FSC grown in Britain would be suitable to show that it's coming from a sustainable source. If you didn't have that evidence, then they wouldn't be able to include that negative biogenic carbon in A1, and it would then make their whole life carbon assessment look very, very bad, because they wouldn't be able to include anything in A1, but they still have to account for the 750 kilograms going back in at C3. So it wouldn't make their building look very good at all. So based on the EPD, they'd be including something like, you know, in A1, based on the Stora Enso EPD again, around 11 kilograms, so 11.71 kilograms of CO2 per cubic meter. And if they're doing a whole life carbon assessment, they'd then also be able to include the minus 73 kilograms of CO2 that's stored in the product. So either one or both of those figures, they'd be able to include in the calculation, depending on whether they're doing the whole life or up front. They'd only include then the transport between the manufacturing plants and from the forest, obviously, to the sawmill, and then the sawmill emissions there are around just under 6 kilograms of CO2. They then need to the architect or contractor would then need to do a calculation to work out the transport emissions. Now, TDUK have done this for timber products. So in the 2024 embodied carbon data, we have done an extensive study on where this timber comes from within the UK and Europe and around the world. So what we've done is come up with some average transport figures for getting that product to a nominal location in the UK. So that's, so for example, for a piece of softwood, it's around 56 kilograms of CO2 in that situation for, I think that's a piece of imported softwood. The contractor would then need to calculate the actual installation emissions of installing that product, and there's some numbers. Again, this would come from the RICS, or they could calculate from actual data. So that's how they'd use the data, and that would then give them that, what we call the upfront figure for carbon. They then need to assess the life cycle performance. So, for example, if they're using some durable timber that they know is going to last 60 years, they might not have any maintenance. If they're not going to treat it, they're not going to put any finishes on it, then there wouldn't be any need to make it allow for any maintenance. But if they're using, some softwood that they know is only going to last 30 years, and they're expecting to replace that after 30 years, then they'd have to include some information in there for that maintenance, repair, replacement. And then they'd have to include something for the end of life stage. And what we're suggesting is that they use the figures that we've got at the moment within some of the TDUK papers, which show the current end of life routes for most timber. So, like I say, most stuff actually goes for biomass at the moment. That's about a quarter going into panel boards, some going into animal bedding, but very little, next to nothing, going into landfill. And if they want to break it down even further, we've got some more indicative figures in the in the TDUK papers, which have also been copied into very similar into the RICS paper as well. And then you need that, like I say, beyond life cycle assessment, how is that timber going to benefit going forward? So, benefits of this, discard from the built assets, any energy recovered from them beyond the product's life cycle can be accounted for in Module D. For example, reuse of an engineered element, or the use of recycled wood chip for panel board manufacture or animal bedding is sort of offsetting the use of virgin products. So that would be in credit for avoiding that to wood chip virgin sources, or if we're burning the timber, so it's used from biomass fuel for energy production, that receives a credit for avoiding production of grid electricity from and thermal energy from, say, natural gas, or in some cases, other countries, it might even be coal still. So it sort of gives you that impact sort of guidance. It's a little bit woody because it doesn't actually go form part of the calculation. It just gives you some other key benefits. So just if you want some help measuring the data, that very much encourage you to look at the net zero roadmap documents that we've got online. You've got the net zero roadmap and the and also lots of spreadsheets and stuff that you can use to measure your data. So that will include things like material flows to show where your products are going, gives you some baseline carbon data for the industry, detailed analysis for the emission sources, things like policy recommendations for reductions that you might want to put in place. Just to bear in mind that to produce your EPD, you will need at least a year's worth of data to be able to produce that EPD is the key bit. And like I say, lots of emission reductions and measurement tools and reporting templates that you can use that will help you to produce that EPD going forward. And like I say, some of the things we've got, the industry flow shows how the material moves around the industry. Key bit, we're interested in that. What we need to do to get to net zero, and the key things is sort of our production emissions, particularly from imports, and also reducing our reliance on fossil fuels for transport. And the key policy recommendations. We won't go through all these now. You can have a read of these in the roadmap at your leisure. But key ones there are obviously about reducing scope 1, 2, and 3 emissions. And when we talk about scope 1, 2, and 3, what are we talking about there? Well, scope 1 is the stuff is where you're using fuel directly for your vehicles or within your plant. So if you're using so if you're sort of, for example, burning gas for kilns or for heating, that would go into scope 1. If you're using diesel in on-site plant, forklifts, etc., that's scope 1. And then you got what we call indirects, which is your scope 2, which is generally going to be purchased electricity. So anything any electricity that you use, but could also include steam or heat that you might be getting from a process that's next door. That could also be included in that scope 2. But one of the biggest areas of your emissions is going to be your scope 3. So that's sort of emissions from outside of your business. So key ones there are going to be things like, you know, the embodied carbon in the purchased goods that you buy. So, you know, if you're buying timber to make into a timber frame wall panel, obviously you're going to have embodied carbon within that timber that you need to account for. We need to transport it to your facility and to your customer, so upstream and downstream transport. And if you're outsourcing that transport, that, you know, is something that's it's a big impact that's not being picked up within your carbon footprint if you're only doing scope 1 and 2 emissions. But it is for the industry, that's a big impact. So those are the sorts of things I think you need to be considering. So some of the things you might want to do, so very much, you know, let's measure your scope 1 and 2 emissions, and we've obviously set standard to compile a full scope 3 by 2025. I'm not sure we'll get to that, but there's lots of tools out there. We've got spreadsheets on the website that Energize have produced for us that are specific for timber industry customers. You've also got their Net Zero Club. If you're a smaller business that hasn't got its own environmental management resource, then the Net Zero Club might be the thing for you, because that includes some consultation advice as well. It's a membership type process. We've got to reduce our transport emissions. So the key one there is going to be our road going transport. There's things we can do now, things like, you know, looking at tyres, optimal inflation pressures, driver training, aerodynamics within the lorries, etc. That can all give you up to 30% improvements in efficiency going forward now. Route optimization is another one. And then going forward, when you're looking to replace your vehicles, you really need to be starting to look at whether you can start over to electric vehicles now. By 2030, I think they're going to be very much the go-to. But you know, between now and 2030, it might be that your business depends on how much, you know, how far you transport your materials, you might be able to use them now. And the advantage for us in the timber industry is that we've got generally a lighter weight product. So we're not, you know, so we can almost fill a truck up and it wouldn't be up to its capacity as far as the weight goes. So that does help us as an industry, and it means we could move quicker to maybe electric vehicles and other sectors, such as, you know, maybe the concrete industry or steel industry that are carrying a heavier product. We do need to look at our, obviously, very much need to look at our manufacturing emissions, and if you're working with your partners overseas, we need to encourage them to improve their emissions as well, because it's that's a big part of our embodied emissions within the product is from overseas production. So we'll very much look at that, and obviously our forestry emissions and reductions in the forest as well. So we need to transition away from diesel, probably to something like hydrogen. I think in the forest, so it's going to be a little bit further away because that technology is still in its infancy compared with electric vehicles. You know, it's not easy to plug in a forwarder in the middle of a forest, so hence it's likely to be hydrogen where we can transport the fuel to that forest location. And we also need to look at things like circular economy and how we might be able to improve that, and how there's courses online. If you look at the PEFC website, I do some courses for them around how we can improve circular economy and how you might be able to get your products back from your customer by using different business models to actually get the product back so you can remanufacture it into another product. Worth looking at some of those. And then once you've done all those reduction emissions, it's then looking at how you might be able to offset the last, and we're saying 10%. We need to get you know, emission reduction down to around less than 10%. We can then look at what we call nature-based solutions, so combined with, you know, forest restoration, etc., around carbon removals for the offsetting side. Not ideal, but there are some key bits out there, and obviously supporting domestic woodland reduction. We need to look at how we support UK productions, because that could reduce that transport as well. There are some tools out there as well for EPDs. The technical paper, the key one, if you want to look into it in a bit more detail, is this assessing the carbon-related impacts and benefits of timber products. That was done with Jane Anderson. founder and director of Construction LCA, who's been a great help to us in the timber industry, and she works across the sector. She does a lot of work across the construction sector. Very knowledgeable person, Jane. She's wrote this paper for us, and we've also sort of turned that into oh, sorry, I clicked on it. It's hyperlinked, but she's also done a summary. It helps us put together a summary document. So if you want to maybe read the blue one first, timber and embodied carbon, that gives you a sort of a feel for it. But if you want more detail, then look at the orange document, which goes into a lot more detail. There are tools out there. One of the ones we've looked at is One Click LCA, and if you look on the YouTube channel, I think we've done we have got a session there we've done with One Click, went through how it worked. And that includes a lot of sort of pre-verified data for the timber industry. So if you've got some initial data, a lot of the other data it can bring in and is already pre-verified. It makes that process a lot simpler. But like I say, there are some training videos there. The One Click LCR on the YouTube channel is a link in there which you can see. And then, like I say, we talked about assemblies. We talked about the AECB carbon calculator. TD UK members get a 15% discount off that. It's a fairly cheap tool anyway. It's a license. I think the license is only 150 quid a year, so it's not a lot anyway. But that can help you bring together assemblies if you work with assemblies and bring different components into a product that you sell on to your customers. And we've got the EPD database. So this is purely at the moment for members that are producing EPDs. And it sort of states the A1 to 3 emissions for the product on there. But you've also got, we've also been working with others like the Future Home Sub iStruct. Now that very much needs members to upload but we need that to produce the 2024 what we call an embodied carbon data for timber products, which we released last year. Sorry, clicking on that again, and that gives you weighted average data for a number of timber products that the engineers and architects are starting to use for their products now. So that's really it from me. A little bit over that 45 minutes. Apologies for that, but not too bad. So I think the call to action for me is to really insist on EPDs from your supply chain. So if you're working with overseas suppliers or UK suppliers, insist on EPDs and upload these to your product profiles on the TD UK website, and then we can hopefully feed them into the EPD database going forward. Where you produce a product, I'd very much encourage you to develop a strategy for the production of your own EPDs. And when these are finalized, again, you can upload them to the TDECO website. Make sure that you're measuring and reporting your scope 1 and 2 emissions. Like I say, for 2023, we want to try and get some data for that going forward. We will have a reporting platform going live, hopefully not too soon. And then start looking at your scope 3 emissions, particularly, like I say, key ones would be the embodied carbon within the products you buy, and also your outsourced transport is going to be a key one there. So looking at outsourced transport, how talk to your transport providers and start to get some carbon data from them. They should have it. Most transport companies will have software that tells them what carbon emissions are being generated. Implement relevant emission reduction opportunities identified in the net zero roadmap for your particular type of business. That will help you save carbon and reduce your cost over time as well. There might be an initial investment, but long term that will give you a saving. And as we are starting to see, we're starting to produce some real case studies on what some of the companies in membership with TD UK are doing, and they're starting to hopefully will come through over the next month or two. Incorporate that circular economy design principles into your production, but also into your sales opportunity. Is it something do you have to sell timber? Could you actually do other types of a business model for that product? Could you lease it? Could you do something else with it? Service models, and they're all explained in the like I say, the circular economy webinar we do with a CPD that we do with PEFC. But that's something you could look at that might be able to enable you to get that product back at the end of its life, especially for short life rotation products. And then support targets an initiative to increase domestic production, things like tree planting schemes and offsetting. So if you are looking at an offsetting scheme, can we look at a UK tree planting rather than tree planting elsewhere in the world? So that's call to action. That's it from me.